now for the final part of the first subtopic, we look into the geometric correction. Before this, we already discussed about the what we call it, the sensor or this image corrections. The first one will be much related on the platform itself. Number two will be much on the atmosphere and so on, geometric, and the third one will be just much on the atmosphere. And now we are talking about the geometric correction, right? So geometric corrections, remember, remote sense image are not maps. We have to remember that our Earth is a sphere. Macam bola is a sphere. So, it is impossible for us just simply capture a flat surface on the sphere. Okay. Where? Okay. Therefore, as we know that a map is a graphic representation on a plane surface. Remember, plane surface means permukaan rata on the Earth's surface or part of it, showing its geographical features. And these are positioned according to the pre-established geodetic control, grid, projection, and scales. So all of this we discussed on the chapter where we about the GIS, or how we transform into a flat surface, okay, a flat surface. However, information is often extracted from images for the integration with a map data such as a GIS. And even remote sensing is a main source of the GIS data. So geometric correction is the transformation of an image data to the scale and projection properties of a map, what we call as a rectification, registration, georeferencing, and there's a lot of name of it. So a related technique is what we call as a registration. And registration, what is registration? Registration is basically a process, okay, a process where we try to fit one image coordinate system to another for the same geographic area. In this way, pixels for a single ground area can be digitally or visually superimposed, and a map coordinate system may not be involved because it still holds the same coordinate system. However, because of the original image is quite skewed, it has curve, and because of we want to make it into a plane, want to make it into a flat surface. That's why we try to pull it, we try to stretch it, just like a rubber. You try to flatten a bended rubber, so you have to squeeze, pull, and so on. Any way that possible for you to make it flat. So geometric correction is required when an image is to be used to perform image-to-image comparison. Usually if you have different sources of images, okay, and confirm with the other geospatial data sets, especially if you have certain images and you have the GIS data, you want to compare, you want to try to register so that the image will be fit almost perfect on the GIS map, and make distance or area measurement. Remember, okay, it's quite difficult for us to measure on the curve on the skewed surface. It's much easier if you have a flat surface. Therefore, flatten it out and do the measurement. And allow identification of specific map coordinates because of we want to tap. Okay, a very simple example will be just like a Google Earth. You open a Google Earth, when you zoom out until you can see the whole globe is all curved. The moment you zoom in, it's simply flatten the surface so that it's easy for you to use it. All right. And to bring other image into a proper registration. Let's say you have another image that you might get from other places, and could be the coordinate. There's no coordinate on the image. So if you want to register the same coordinate to that new image with the same coordinate you have, you can do that, no problem. So sources of geometric error in certain imagery are instrument error due to optical system distortion. We know that it's just that you capturing you using the camera, okay, because of our lens is quite skewed. Yes, there has this what we call as spherical lenses. All right, so what happened? it have a slight distortion on the edge of the image. All right. Or it could be because of due to scanning mechanism faults. All right. So this is all about the instrument. And of course, panoramic distortions is due to earth curvature, especially with the wide angle instrument, just like what I show on your previous lab. Earth rotation. Okay, remember, earth rotation will skew an image because you have to remember our earth rotates 2000 kilometers per hour. It's very fast. So what happened is, because of the movement is quite fast, okay, after the satellite, after the satellite scan, okay, and then the earth skewed, and the next scanning will be quite further west because of the earth has rotated slightly to the east, right? Because our earth from west to the east. And platform instability is because of variation of altitude, especially you doing using an airborne aeroplane or drone, okay, due to terrain and sensor, as well as the attitude of the platform itself. Terrain, sensor pitch, yaw, roll, and velocity. Inconsistent velocity might also influence it. Direction, the wind direction might also influence it. Wind speed also influence it. There's a lot of factors that can influence the quality of your data. So geometric correction is quite critical. All right. Instruments error, panoramic distortion, rotation are form of systematic error where it can be predicted and easily corrected automatically. Usually, for any data provider, they will do this for us. Let's say you are downloading data from the NASA website. They already cover all of this. Only the proper registration to fit in to the local projection is the only thing that you require to do. It's quite simple. Alright. However, platform errors are unsystematic, okay, due to platform various conditions or environment that they just fly. Okay, we can't really forecast what happened. We can't really see the wind direction goes where and when. The competency of the pilot itself, even though you use drone, if you have a slippery hand, so basically you might have a difficult time to handle your drone, okay, and so on. And they are unpredictable and must be corrected using a system of the ground control points. Okay, so ground control points are specific image pixels or location on a map where geographic coordinates are known. So GCPs are used to correct geometric distortion in an image by matching image coordinates with a map coordinate. So if you fly using your own platform, let's say using drone, it is a good practice where you identify several features, or maybe you can have your own GCPs, take the coordinate using your GPS and collect the coordinates. Then after you fly, you have to re-register the image. Although the image might have the GPS, but you have to make sure that the image that shows your ground control point, the position, the location, the coordinates, it's tally with the one that you captured on the ground. Okay. So how geometric correction process do, or what to do? The first one, determine the relationship between the coordinate system of the map and on the image, or between one image to another when register through the GCPs, just like what I explained just now. And after that, the system will calculate the pixel coordinates in the corrected image, and after that, they estimate the pixel value to be associated with the corrected pixel coordinates. They will do the resampling, do and do, until it finishes the whole image. Alright? And what is GCPs, or ground control points? So ground control points should be readily identified. It's a way you use any features, any landmark that are visible. Okay, you get the coordinates and it becomes a main reference for you to register your coordinate to ensure that your coordinate is accurate. Okay, this is a normal practice for any remote sensing data collection. Although you using the satellites, okay, or maybe you use aeroplane, drone, and so on, is a must. Okay, GCPs should be readily identified and of any ambiguous collocation. Mean to say, you know that it's quite easy for you to detect on the image. So nevertheless, okay, different resolutions you can detect the features that you use or the landmark that you use as your GCPs. And they should be evenly distributed. Remember, the image is just like something like this, square. So it is good that you have one on the left, upper left, another one will be on the upper right, lower left and lower right. So it evenly distributed, and it can help you to register without creating more and more distortion and skewness. Okay, and the good one will be minimum 4 for every edge of the image. But of course, you can do more than 4. It's much better. Alright, so the good GCPs includes any physical features that can be easily determined. It will not change in a short time. Alright, and you are familiar with it. Meaning to say, it's quite obvious. It's not something that only you know. It's something that is quite obvious. Everybody can detect it itself. So the one will be the road intersections, airport runways, utility right-of-way, large buildings, non-mobile. You cannot use cars because car moving. Okay, you cannot use any human made, like just example would be trees, because it quite difficult for you to determine the differences between one tree to another. River as well. Okay, so identifiable features of which GPS coordinates are available or can be collected. It could be the one that has their own GPS coordinates, or it could be you go to the ground, you collect the GPS coordinates, and you go back and you do registration. And bad GCPs includes water bodies. Why? Because water will not static. It will flows, number one. The level of the water also will be different. High tide, low tide, rainy season, dry season, all of this will affect the coastal line of the water bodies. Vegetation features as well, of course, you cannot simply detect the differences between one tree to another tree and other natural features. So they have two types of the registration, image to map and image to image. Image to map means you have one map that have coordinate, and you try to register to the you have try to register this image to the existing map, the GIS map. While image to image, one data might have the image has been coordinated, has been registered, and another new image you want to re-register so that it will be very accurate on the same one. So this is the GCP. Okay, this is the GCP. This is how we do registration. So the choice of ground control points depends upon the image scale. Alright. So common sources of the GCPs are relatively large scale imagery, right? Or it could be from the topography maps, or maybe using the GPS. So what happened is Cook and Pinder compared accuracy of rectification using GCPs derived from map versus the GPS. They determined that GPS provides substantially better result than map digitizing. Why? Because using GPS, even now, your handheld GPS is quite accurate, 3 meters of radius. Okay. Then map digitizing, because somehow we can question the quality of the digitized map due to the competency of the one who digitized it, because it's all created through human. All right. So that's the end of the final part of the first subtopic.